This is a singer. I am a tenor voice with a blue or sky blue shirt. Oh, nakakaloka. O, diba? Okay, guys, so let's continue about atomic mass and atomic weight. I don't have to talk about politics because I don't have an idea. Really, okay? So I don't want to create argumentations, hated speech, bullying, or, conflicts of ideas, views, and opinions, clash of, different philosophies in life regarding politics. I don't want to tackle that one also. And I need to tackle in things and in areas in which I am convenient the most. And this is my profession. Okay, something like that. So, okay, I need to introduce the most common. Guys, when I was really in high school, I started to memorize basic atomic masses and atomic weight of different kinds of elements. And then, some are disappeared and some are retaining in my brain cells and some are disappeared. And then when I stepped up to college level of education, then I have already the advantage because, it's stuck in my brain cells. Okay, the basic principles and concepts of chemistry, so I don't find any difficulties, really. Okay, and then so it's being useful also in higher subjects, science subjects related to BS chemical engineering. Okay, so actually, guys, disclaimer, we have different ideas. They said physics is the best tool in BS chemical engineering, but for me, it's not. It's chemistry. Really? Okay, so I need to discuss why, I need to justify why. Okay, because some topics of physics are already discussed in chemistry. Yes, the different types of energies are already discussed in chemistry in the last part of a textbook. If you have a textbook, orange color, authored by Fred Moore, okay, orange color, the thick one, like that. So you can easily see there that the parts and the concepts of energies are discussed in the last portion. What are those energies? Kinetic energy, potential energy, motion, speed, velocity, acceleration, even though chemistry, but it's already tackling or already discussing about some topics of physics. Okay? Like that. And then also, if you insist that this chemical engineering are more on physics, then why it is not called BS physical engineering? Okay, so you need to be clever. Okay, that's why it's called BS chemical engineering because the word chemistry is linked with the word chemical. It's not physics. You get a point? Anyway, we have different opinions, but for me, really, it's chemistry for me. Okay, because chemical is chemistry, right? So this is BS chemical engineering. So if you insist really that the solid foundation of BS chemical engineering is physics, then it could have been BS physical engineering, right? Because physics, physical, okay, chemical, chemistry, right? So the solid and basic foundations of chemical engineering is really chemistry, not physics. Sorry for you, I have to defend this, okay? Nakakaloka. Diba? Okay, then, remember also, guys, the father of chemical engineering. Remember who is the father of chemical engineering? So if we have the father of physics, which is Mr. Isaac Newton, and we have also the father of chemistry, which is Antoine Lavoisier, we have also the father of chemical engineering. You know or not? Any chemical engineers listening to me right now, or whether licensed or not? Okay, so it's gonna be George Davis, the father of chemical engineering. Okay, now if we speak about chemical engineering, our really focus is the conversion of useful raw materials into very beneficial products or yields through the process of technology and the application of mathematics. Okay, the math and the technology will be combined, okay, to be used in a larger scale, different processes and operations that mostly the chemical engineers will be dealing to, something like that. So product, raw materials, like that, blah, 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 so and so. Then you can optimize your products, and that's the time you will be able to design very beneficial different units. Units meaning different equipments. That's why we have unit operations. Units are those equipment that involve in different separation processes. Could either be a physical and chemical separation processes. Okay? That's the study of unit operations and the unit processes. Now, I will tell you, that's not the heart of chemical engineering. Okay, what is really the heart of chemical engineering? Okay, the heart of chemical engineering, HEART, is the chemical nuclear reactor, meaning the chemical reaction engineering. Okay, the chemical kinetics is the heart of chemical engineering, meaning really chemical reactions involve the rate, the chemical reaction rate, the rate law, the first rate law, the determining step, the reaction mechanisms. That's why we are very, very useful in any nuclear power plant. Okay, so because the chemical engineers can design a nuclear power plant. Okay, something like that. So it's not really the unit operation, unit processes, it's not. It's the kinetics, chemical kinetics and chemical reaction engineering. So when we speak about chemical reaction, that's mainly coming from chemistry, not physics. So therefore, we conclude the basic foundation of BS chemical engineering is chemistry, not physics. Okay, and take note also, based on my research, physics is only the umbrella of chemistry. Chemistry is really the background of all. Just like the sun, the center of the solar system in which the 9 planets revolve on the orbits, and the center in the solar system is the sun. So chemistry also is the center of all sciences. Okay, I discussed this already last month, I think so, right? So outside will be the physics, the biochemistry, the plant science, the animal science, the environmental chemistry, environmental science, the earth science, like that, the medicines, oh my gosh, the nuclear, like that, the metallurgy, the mining, the geology, studying the earth's crust, something like, or the seismology. So really guys, the chemistry is in the center. Okay, meaning the parent, pure science of all is chemistry. Okay, if you want to argue with me, then you can chat with the FB Messenger and we will discuss professionally why. Okay, like that. Okay, now going back to expressing different atomic masses and atomic weights. Okay, sorry guys, I really love chemistry. Okay, something like that. Okay, mga palangga. Okay, now I need to discuss the common. Let's start first with carbohydrates family, right? So the sugars, something like that. Okay, so carbohydrates, ganon. Okay, carbohydrates. Oh, nakakaloka. Investigate the term first. Carbo. Oh, carbos coming from the word carbon. Okay, this gonna be a way to understand properly by looking and scrutinizing the terminology or the term. Okay, it's gonna be coming from carbon. Hydrate coming from hydrogen. Okay, hydrogen. Now let's connect the word hydrate. Okay, so when we mean dehydration, the water is being removed from our system. Okay, and we say hydration, meaning the water is added. It's just the reverse, right? Okay, so it's gonna be hydrogen. Okay, something like that. So carbon, hydrogen, and the oxygen will be there because oxygen is an element or a component of water, of H2O, if you try to break down that one. Okay, so that's why CHO. Okay, or the CHO, something like that. The empirical formula of carbohydrates is CH2O. Okay? And then the general formula is C6H12O6. What's the difference between the general formula and the empirical formula? Okay? The empirical formula is really expressed in a small mole ratio, the smallest mole. But this glucose is more on the higher number of moles or atoms. Okay? Starts with the glucoses family. Okay? You get the point mga palangga? Glucoses or glucose. Okay. You get the point? Okay, muna na siya. So, carbon. Oh, mag-start sa carbon mga palangga. Okay. Carbon, hydrogen, oxygen. And now we go to, let us say, protein. Protein composed mainly of amino acid, carbonyl group, and also hydrogen group, right? Meaning to say amino nitrogenous base compounds. Okay, so we have nitrogen, okay, sulfur, and then we add also phosphorus. Wow, I love phosphorus. Why? I can still remember when I was, a product quality engineer of Coca-Cola Bottlers Philippines in Tagbilaran, Bohol, in our quality assurance department. So when we compute the proportion of phosphoric acid diluted, oh, there's phosphorus always like that. And then I love to compute the proportions, and then we give that to the chemists and they try to mix that there. But our computation is our responsibility. Okay, something like that. Okay, now what others? It's gonna be Alkali Group, right? The group 1A family. So we have lithium, okay, sodium, nakakaloka, potassium, rubidium, cesium, and francium. Wow, francium, nakakaloka. Okay, after francium, guys, I read in one of the sources I found, it's gonna be there's a new element discovered, the unonium. And then after this, there's a organazon after the francium that was discovered in 2018, the latest element discovered, but was not yet fully synthesized. Meaning to say it could not be reflected yet in the periodic table officially, but that's ongoing right now. So it takes a longer time. Imagine 2018 and now 2022. It takes 4 years, but this organazon unonium element is not yet fully synthesized. Imagine it takes a longer time for a scientific research to be successful, to be proven to be true, correct, and to be tested successfully. Okay, experimentally, something like that. Okay, going back to francium, and then we go now to the group 2A, which is the alkaline earth metals. Okay, we have the beryllium. Okay, of course, we have the magnesium, calcium, nakakaloka, strontium, and we have the barium, and then the radium. O, diba? Radium, Ra. Ganon. So now we go to the family of halogen. I love the halogen. Okay, the halides. Okay, we have the fluorine, chlorine, bromine, iodine, and astatine. Oh, ganon. And I love also the group 8A and group 0, right? Okay, so this is gonna be the noble gases. Okay, helium, neon, argon, krypton, xenon, and radon, like that. So these are noble gases and reactive, very stable. Okay, noble gases. Okay. So in other books, these are also called inert gases. Okay, like that. So, but the right and appropriate term really is noble gases. Okay. Now we supply different atomic mass now. Okay, carbon 12, hydrogen 1.008, oxygen 16, nitrogen 14, sulfur 32, lithium 6.94, sodium 23, potassium 39.1, rubidium 85.47, cesium 133, francium 223, beryllium 9.012, magnesium 24, 1230, right? Calcium 40.08, strontium 87.62, barium 132.327, radium 226, okay, fluorine 19, chlorine 35.45, okay, bromine 79.70, iodine 126.90, astatine 210. Okay. Are you following me? Yes. Okay, helium 4. This atomic mass and atomic weight you should memorize. Okay? Neon is 20.18. Argon 39.95. Krypton is 83.80. Xenon is 138.3. And radon triple 2, 222. 220. See? So how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28. 28 elements. Okay, plus ato man siyang punan. Okay, of mga transition elements and then a little bit of representative elements. Okay? So, in the problem solving in the future, it cannot escape. Okay? Because usually they are always given the common. Okay? Like that. So, it's going to be like that. So, let's start with copper. What is the atomic weight of copper? Okay. It's going to be copper is 63.55 grams atom. Zinc. Okay. Zinc is 65.38, like that. And then chromium, mga kapatid, chromium is gonna be 52. Okay. Manganese. Okay, manganese is 54.94, like that. Bismuth. Oh my gosh. Bismuth is 208.98. Wow. Polonium, PO. So polonium is 209, right? Like that. And then we go to silicon, okay? The largest component of sand or soil. Then it will be put into the compound known as silica, SiO2. But silicon is 28.28. Okay, like that. Oh my gosh. Phosphorus. Okay, what is the molecular weight or atomic weight of phosphorus? 30.97. Sulfur, 32. Ganon. Okay, selenium. Okay, 78.96. Okay, beryllium, 127.6. Tungsten, W, 183.8. Makakaloka. Antimony. Oh, antimony is SB from the word stabnium, Greek word. Stabnium, right? It's gonna be 121.8. Tin, SN is gonna be 118.7. Okay? Ganon. So, the most precious element is gold. Gold is gonna be aurium, right? Or AU 197. Okay. Silver, nakakaloka. So silver, okay, Ag is equals to 107.9. Okay. Cadmium, 112.4. Mercury, wow, I love mercury. It is used in measuring the blood pressure of the human being. Okay, mercury is equals to 200.6. Okay, lead, oh, lead is very popular, right? Lead is 207.2, mga palangka. Oh, diba? Now we go to the radioactive elements. We have the uranium. Uranium, the heaviest element. Okay, 238. Okay, plutonium, oh my gosh, 244. Platinum, an element used as a construction of material in making an airplane. Okay, platinum is 195.084. Palladium, 106.42. Ganon. Iridium, IR, right? Iridium, IR is equal to 192.47. Ganon. Okay, what else? Cesium kalas na siya, right? Okay, so 28, we add this one. 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. So 52 elements, okay, plus promethium. Okay, promethium is the radioactive element found in lanthanide series. The second to the last. Okay, lanthanide or lanthanide series. Lanthanide and lanthanide is just the same, guys, ha? Okay, it's gonna be promethium. So PM, okay, it's gonna be 145 grams per atom. Okay, ganon. So what else? Can you name? What else left? Okay, so we have aluminum, right? Aluminum is 26.98, right? It's gonna be like that. Oh, I missed. Iron, 55.85. Okay, like that. Okay. Cobalt. Cobalt. What is the atomic mass of cobalt? Okay, it's gonna be 58.93, right? Okay, like that. You get the point, mga palangga? Okay, and then nickel also. Nickel is 58.69. Oh, how many na? 52, 53, 54, 55, 56. So 56 elements. At least you've memorized 56 elements, atomic masses, and atomic weights. Then bingo, you can easily determine the molecular weight, molar masses of a compound, especially in the computation of stoichiometric relationship in different chemical reactions. This will be used. This will be like in the molar mass together with the masses. Okay, like gram to moles, moles to gram, then barren. You can also compute this through heat. Enthalpy change of reaction, especially when the specific heat capacity is given as molar heat capacity. Take note, the unit of the compound is grams per mole. And this compound composed of a lot of elements. When you add them all, it will become a compound. So the grams per mole multiplied by calorie mole, Kelvin, yes, multiplied by, no, flip that out, cancel the mole, so it will become the heat as calorie, right? So this will be useful all the time, okay? In the calculation also of heat energy, okay? Not only for the molecular weight, like that or whatever. Okay, you got the point, mga palangga? Okay, it's gonna be like that. Okay, any questions so far for the different atomic masses and atomic weights? Okay, 56 lang siya guys because hindi na ako makaya. Charot! Okay, like that. So there are still, we have 118 elements found, so 118 minus 56. So I have still 62 elements were not memorized. Okay, so imagine, 62 pa ang wala, 58, 56 lang ang memorize na ako. Okay, like that. Then we need to have the summary now. Summary. Okay, summary. Nakakaloka kasi summary, di ba? Summary, mga palangga. There are at least 94 metals. Okay, in the periodic table. Around. It depends on the sources of the book. Some will say 92, some will say 93. That's why I say around. Okay? And then non-metals is 17. Okay? The gases, the halogens like that. Okay? The noble gases like that. 17. Okay? The radioactive is 38. 38 metals. 38 radioactive elements. Okay? Now, these are composed of artificially prepared and naturally occurring. Artificially prepared, meaning synthesized in the laboratory. Artificially prepared and naturally occurring. Meaning to say, naturally occurring without synthesizing in the laboratory, right? Naturally occurring, okay? Or we call that as a norm, N-O-R-M, naturally occurring radioactive metals. That's why norm. Some books will put that immediately without discussing what is the meaning for N-O-R-M because it's understood to be studied already in the general chemistry lecture. Okay, like so it's gonna be the summary, the statistics of our periodic table. 94 metals, 17 non-metals, and 38 radioactive. Okay. Now, there's only one radioactive element in the lanthanide series, the promethium, as I told you. Right? Promethium. 145 grams atomic mass. Okay? The all actinide group are all radioactive. Okay? Again, all radioactive elements found in the actinide series. Okay? Comprises of this 38. Only one found in the lanthanide series, and the others are distributed already in the main drawing of the periodic table. It could be the center, it could be the left, it could be right. Scattering ito mga radium. Okay, radium belong to group 2A. Yes. Okay, and then we have also the radon, group A. So something like that. We have also the cesium, Group 1A. So these are also radioactive but scattering somewhere else. Wala ni kuyog dito nila ni actinide series. Diba? Tridor. Nakakaloka. Okay. So hindi sila kakampinks. Okay? Because they are scattered to different places in the periodic table. Okay? So any questions so far mga palangga kong hitad? Okay, nothing else. Okay? Okay, any questions so far? So if there's no question anymore, then I will say you can comment in the comment section. You can like also, or you can share also, guys, like. And then, of course, you should subscribe my YouTube channel if you like. I will be grateful if you do that. And then click the notification bell for some news updates that I am seeing. Thank you so much for the people who watch my YT videos. Okay, my other videos are growing really. Thank you so much. Bye bye. God bless everybody.